On the morning of June 30th, 1908, the sky over Siberia turned white-hot, and a blast ripped across the wilderness with a force of nearly 1,000 Hiroshima bombs. Eyewitnesses 90 miles away were knocked off their feet. A man on his porch 60 kilometers from the blast felt heat so intense he thought his shirt had caught fire. And yet, when scientists finally reached the site nearly 20 years later, they found something impossible. 80 million trees flattened in a butterfly pattern across 2,000 square kilometers. But no crater, no meteorite fragments, and no obvious cause. Something detonated above the Earth with the force of a modern nuclear weapon, and it left almost no physical trace behind. By the end of this video, you'll understand what scientists now believe actually happened that morning over the Tunguska River, why it took decades to even get close to an answer, and why the same thing could happen again tomorrow with zero warning. The strange part is nobody investigated for 19 years. Russia was consumed by revolution, war, and Stalin's rise, so the remote Tunguska region near the Podkamenia River sat forgotten. It wasn't until 1927 that a mineralogist named Leonid Kulik finally trekked into the Siberian taiga with a small team, expecting to find a giant meteorite crater and maybe even valuable iron ore. What he found instead defied explanation. Trees were snapped and laid flat in a massive radial pattern, all pointing away from a central zone, like spokes on a wheel 80 kilometers wide. But at the very epicenter, trees were still standing upright, stripped bare of branches and bark, scorched like telephone poles. There was no crater anywhere. Kulik spent years searching lake beds and swamps for meteorite fragments and found nothing. The explosion had clearly happened. The destruction was undeniable, but the thing that caused it seemed to have vanished in a thin air. So what actually caused a blast that powerful to leave no rock behind? The leading modern explanation is that a space rock roughly 60 to 190 meters wide, moving around 27,000 kilometers per hour, never actually reached the ground at all. Instead, the friction and pressure of slamming into Earth's atmosphere caused it to shatter and vaporize 5 to 10 kilometers above the surface, releasing an estimated 10 to 15 megatons of energy in a single instant. That's roughly 600 to 1,000 times the energy of the Hiroshima bomb, released as a shockwave rather than a ground impact. This is called an airburst, and it explains everything Kulik found. The radial pattern of fallen trees, the standing but scorched trees directly beneath the blast, and the total absence of a crater or meaningful debris, because most of the objects simply turned into dust and gas high in the sky before gravity ever got the chance to finish the job. Here's the part that made scientists worldwide take notice before anyone even knew where Tunguska was. For several nights after the explosion, people across Europe and Asia reported skies glowing so brightly at midnight that Londoners could reportedly read newspapers outdoors without a lamp. Seismic stations as far away as England registered the shockwave rippling through the ground like a small earthquake. Barometers in Britain detected the atmospheric pressure wave passing not once, but twice as it circled the entire planet. The dust and ice particles blasted into the upper atmosphere scattered sunlight for days, creating a phenomenon later called noctilucent clouds. In other words, a remote patch of Siberian forest that almost nobody had ever heard of managed to visibly alter the sky over an entire hemisphere. And it did all of this without a single confirmed human death, largely because the region was so remote that almost nobody lived there. Now consider the timing, because this is where Tunguska stops being just a historical curiosity. The object exploded over one of the most sparsely populated places on the planet. Earth rotates roughly 15 degrees every hour, and the planet had simply turned enough that just a few hours difference in timing would have put that same blast directly over St. Petersburg, then the capital of the Russian Empire, or over a major European city. A modern airburst of that size over any city on Earth wouldn't flatten trees. It would flatten buildings and kill hundreds of thousands of people in seconds, with a flash and shockwave arriving faster than any warning could travel. Tunguska wasn't a freak one-off event either. Scientists estimate airbursts of this rough scale happen on average every few hundred to roughly 1,000 years, which sounds rare until you realize humanity has only been capable of detecting them for a few decades. So has anything like this happened since? Yes, and far more recently than most people realize. On February 15, 2013, a much smaller asteroid, only about 20 meters wide, exploded over Chelyabinsk, Russia, releasing energy equivalent to roughly 30 Hiroshima bombs. Nobody predicted it. It came in daylight, invisible against the glare of the rising sun, and the shockwave blew out windows across 6 cities, injuring around 1,500 people, mostly from flying glass. Chelyabinsk was maybe 1/400th the size of the object believed to have caused Tunguska, and it still made global headlines and briefly shut down a city. It proved that modern tracking networks, built specifically to watch for civilization-ending asteroids, can still be completely blindsided by something smaller, faster, and coming from the wrong direction, like straight out of the sun where no telescope on Earth is currently looking. Even with the airburst theory widely accepted, Tunguska still hasn't given up all its secrets. In the decades since Kulik's first expedition, researchers have found microscopic traces of nickel and iridium in the soil, tiny glassy spherules consistent with vaporized rock, chemical fingerprints suggesting the object really was a stony asteroid rather than, say, an icy comet fragment, which was once a popular alternative theory. In 2013, a team of scientists even claimed to identify tiny meteorite fragments recovered decades earlier from the region, though the debate over their exact origin hasn't fully settled among researchers. Some scientists have also pointed to a nearby lake, Lake Cheko, wondering if it could be an impact scar from a lingering fragment, though most current evidence argues against that idea. More than a century later, Tunguska remains one of the best documented, least understood explosions in recorded history. So here's the real twist. Tunguska wasn't caused by a secret weapon, an alien spacecraft, or a volcanic eruption, despite decades of wild theories chasing exactly those ideas. It was simply a rock from space, smaller than a football stadium, that happened to arrive at the wrong angle over the wrong patch of sky. And that's precisely why it matters. It's proof that an object too small for most defense systems to prioritize can still unleash more energy than the largest weapons humans have ever built, arriving with no siren, no countdown, and often no warning at all. Every single day, Earth is quietly struck by roughly 100 tons of space debris, almost all of it burning up harmlessly. Tunguska is the reminder of what happens on the rare day it doesn't. Somewhere out there, the next one is still traveling toward us, and nobody currently knows its name. Subscribe for more stories like this.